Welcome back. I'm here with our instructors for this week, Mike and Shelby. Last week, you learned about transformer networks, which is really a key foundation for large language models, as well as the generative AI project lifecycle. And this week, there's lots more to dive into, starting with instruction tuning of large language models, and then later, how to carry out fine-tuning in an efficient way.
Yeah, so we take a look at instruction fine-tuning. So when you have your base model, the thing that's initially pre-trained, it's encoded a lot of really good information, usually about the world. So it knows about things, but it doesn't necessarily know how to be able to respond to our prompts, our questions. So when we instruct it to do a certain task, it doesn't necessarily know how to respond. And so instruction fine-tuning helps it to be able to change its behavior to be more helpful for us.
I thought instruction fine-tuning was one of those major breakthroughs in the really history of large language models, because by learning off general text off the internet and other sources, you learn to predict the next word. But predicting what's the next word on the internet is not the same as following instructions. I thought it was amazing that you can take a large language model, train it on hundreds of billions of words off the internet, and then fine-tune it with a much smaller data set on following instructions, and just learn to do that.
That's right. And one of the things you have to watch out for, of course, is catastrophic forgetting. And this is something that we talk about in the course. So that's where you train the model on some extra data, in this sense, instruct fine-tuning. And then it forgets all of that stuff that it had before, or a big chunk of that data that it had before. And so there are some techniques that we'll talk about in the course to help combat that, such as doing instruct fine-tuning across a really broad range of different instruction types. So it's not just a case of just tuning it on just the thing you want it to do. You might have to be a little bit broader than that as well. But we talk about it in the course.
And so it turns out that there are two types of fine-tuning that are very worth doing. One is that instruction fine-tuning that you just talked about, Mike. And then when a specific developer is trying to fine-tune it for their own application, for a specialized application, one of the problems with fine-tuning is if you take a giant model and you fine-tune every single parameter in that model, you have this big thing to store around and deploy, and it's actually very compute and memory expensive. So fortunately, there are better techniques than that.
Right, and we talk about parameter efficient fine-tuning, or PEFT for short, as a set of methods that can allow you to mitigate some of those concerns, right? So we have a lot of customers that do want to be able to tune for very specific tasks, very specific domains, and parameter efficient fine-tuning is a great way to still achieve similar performance results in a lot of tasks, on a lot of tasks that you can with full fine-tuning, but then actually take advantage of techniques that allow you to freeze those original model weights or add adaptive layers on top of that with a much smaller memory footprint, right? So that you can train for multiple tasks.
Yeah, no, in fact, one of the techniques that I know you've used a lot is LoRA. I remember when I read the LoRA paper, I thought, oh, this just makes sense. This is going to work.
Right. We see a lot of excitement, demand around LoRA because of the performance results of using those low-rank matrices as opposed to full fine-tuning, right? So you're able to get really good performance results with minimal compute and memory requirements.
So what I'm seeing among different developers is many developers will often start off with prompting, and sometimes that gives you good enough performance, and that's great. And sometimes prompting hits a ceiling in performance, and then this type of fine-tuning with LoRA or other PEFT techniques is really critical for unlocking that extra level of performance. And then the other thing I'm seeing among a lot of LM developers is a discussion debate about the cost of using a giant model, which is a lot of benefits, versus, for your application, fine-tuning a smaller model.
Exactly. Full fine-tuning can be cost prohibitive, right, to say the least. So the ability to actually be able to, use techniques like PEFT to put fine-tuning generative AI models kind of in the hands of everyday users that do have those cost constraints and they're cost conscious, which is pretty much everyone in the real world, right?
That's right. And of course, if you're concerned about where your data is going as well, so if it needs to be running in your control, then having a model which is of an appropriate size is really important.
Right.
And so, once again, tons of exciting stuff to dive into this week. Let's go on to the next video where Mike will kick things off with instruction fine-tuning.